If you've ever used Spring Data JPA, you've probably had this moment where you stop and think, wait, how does this actually work? How can I query a database without writing a single line of implementation code? Well, today, we're pulling back the curtain on that magic that saves all of us developers so many hours of writing boilerplate code. Let's get into it.
I mean, it sounds a little bit like magic, doesn't it? The idea that you can have a totally functional data access layer just by defining an interface. This is the big question we're going to tackle. And spoiler alert, it's not magic, but it is some seriously clever engineering.
Okay, so everything has to start with our data model. Let's take a look at this super simple person class. It's really just a plain old Java object, a POJO, but it's marked up with JPA's @entity annotation. It's got an ID, it's got a name, nothing out of the ordinary here. This is the thing we want to save and get back from our database.
Now this is where things start to get interesting. This is the repository for our person entity. It's just an interface, person repository, and it extends Spring's main repository interface. But look closely. What's missing? There's no class that says implements person repository. We don't write one, so what's going on?
Well, this isn't some bug or oversight. As the official Spring Data documentation tells us, these repository instances are automatically implemented for you at runtime. This is the whole point, the core feature that makes Spring Data so incredibly powerful. You just define the contract and Spring handles the heavy lifting of the implementation.
So that leads us to the main event, right? If we're not writing the code, who is? And how does Spring know what code to write? It's time to peel back the layers and see exactly what's going on behind the curtain.
The whole journey really starts with a set of really powerful, well-designed interfaces. These are the foundation of this entire repository abstraction.
So at the very top of the food chain, you have the repository interface. Think of it as a marker. It's a generic interface that takes two things: your domain type, for us that's person, and the type of its ID, which is long. Its main job is just to act as a signpost, signaling to the Spring container, hey, this is a data repository interface that you need to take care of.
And this is where you see the immediate payoff. Most of the time, you're not just going to extend the base repository, you'll extend CrudRepository. And just by doing that, you instantly inherit all these standard methods for create, read, update, and delete. Things like save, findById, delete, all that boring, repetitive boiler code you used to write for every single entity, poof, it's gone.
And the abstraction doesn't stop there. If you need to handle big data sets with pagination and sorting, you can use the PagingAndSortingRepository. If you find iterable a bit clunky and would rather work with a list, there's ListCrudRepository. And for JPA-specific stuff, like flushing the persistence contact, you've got JPARepository. You just pick the tool that's right for the job.
Okay, so we've got these awesome interfaces, but how does Spring find them and then magically create the implementations? Well, that all comes down to configuration.
You've basically got two ways to tell Spring to do its thing: the modern way, using Java config, or the old-school legacy way with XML. Now, XML is still supported, but let's be honest, almost every new project these days uses Java config with annotations. They both get you to the same place, but Java config is just cleaner and feels more natural in modern Java.
And really, this is the secret sauce. This one little annotation, @EnableJpaRepositories. It's like flipping a switch. When Spring sees this in one of your configuration classes, it kicks off a scan of the package. It's looking for any interface that extends repository, and for every single one it finds, it generates a proxy implementation bean at runtime. That's it. That's the magic.
Now, the default behavior is fantastic for most cases, but what about those more complex scenarios? Well, Spring Data gives you plenty of tools to fine-tune exactly how your repositories get defined and created.
Okay, so let's say you want to create your own custom base repository, one with some common methods that all your other repositories will share. If you do that, you have to remember to mark it with @NoRepositoryBean. This annotation is you telling Spring, hey, this interface is just a template for other repositories. Don't you try to create an implementation of this one directly. It's absolutely essential for building your own reusable abstractions.
So what happens if your app gets really complex? Like what if you're using both JPA for a relational database and Spring Data MongoDB for a NoSQL database? How does Spring know which repository belongs to which? It's got a few clever tricks. First, it'll check if your repository extends a specific one, like JPARepository. If not, it'll look at the annotations on your actual entity, like @entity for JPA. And if all else fails, you can just explicitly tell it which packages to scan for each module.
All right, time for a pro tip.
By default, Spring initializes all these repository beans eagerly when your application starts up. Now, for big applications, this can actually slow down your startup time. But don't worry, you can control this.
Spring Data gives you this thing called a Bootstrap mode. The default is eager, but you can set it to lazy, which means Spring only creates the actual repository bean the very first time you use it. This is a game changer for speeding up your tests and local development. There's also a deferred node, which is kind of a smart middle ground for certain advanced applications.
So let's just quickly recap the whole magic trick. 1. You define a super simple interface. 2. That add EnableJpaRepositories annotation kicks everything off. 3. Spring finds your interface and generates a dynamic proxy class behind the scenes to implement it. And 4, just like that, you get a fully functional data layer with zero boilerplate. It lets you focus on your business logic, not the plumbing.
So there you have it, the magic is revealed. It's really just a powerful combination of marker interfaces, runtime proxy generation, and some really smart configuration. So I guess the real question this leaves us with is this. Now that you don't have to worry about writing all that boilerplate data access code, what amazing complex business logic will you build instead?